Hey, this is Josh from Leet Dev, where our goal is to explain LeetCode problem as simple and concise as we can. Today, we're going to talk about one of the oldest joke interview questions that there is. How do we reverse a linked list? Well, this video ain't no joke, and the problem is still a good introduction to thinking about pointer manipulation, so let's get started. The problem statement is straightforward. Given a linked list, we want to reverse it. So our example is given the linked list 1, 2, 3, 4, 5. We want to return another linked list that is 5, 4, 3, 2, 1. We'll be doing this both iteratively and recursively. Despite this problem being labeled as an easy question, I consider it only easy if you know the trick behind it. The idea might become more intuitive if we look at a smaller problem instead of 1 through 5. For example, how would we reverse a linked list of 2 elements by only manipulating a pointer? Well, the first thing is we would take our next node, we would set its next to be our first node. Then we would just eliminate the next node of our first node. And then finally, we just point our head to be the next node. And then there we go. We have our reverse linked list. To summarize our algorithm into 3 steps, we have our current node, which represents the node that we're currently looking at, and another node next, which just represents current.next node. To solve this problem in 3 steps, first, we would set our current node to be next's next. So this would now point over here. And then step 2, we would set our next's next node to point to the head. It's important to be the head and not current because we want it to be in the front of our node now. Notice that we don't actually lose track of 3 because our current node now points to it. And then in step 3, we will set our next to be the head. So this would point here. Now we will summarize it. Now if we look at our linked list, head would point to 2, which then would point to 1, which then points to 3. Now let's clean this up a bit. All right, so we moved it around, but we should readjust the pointer. Next no longer exists. Current is still at 1. And now we'll just define another variable next, which will represent the next linked list, which is 3. And then we can follow the exact same algorithm. We would set current's next to be next's next, which in this instance is nothing. So this would be gone. We would set next's next to point to head because we want to point to whatever was formerly the front of the list. So now this would point to 2. And then finally, we want to set our next to be the head. If we follow this pattern again, we start at head points to 3, 3 points to 2, 2 points to 1, and 1 points to nothing, and then we have reversed our linked list. Now let's quickly go through this problem. So first, let's create our nodes. Just like the live example earlier, we will continue rearranging nodes until our current.next is null. It's also important to mention that we also checked if current itself is null, and the only instance this would happen is if we were given a null head. Now let's define our next. And then we would do the reattachment like we talked about before. First, we set our current.next to be next.next. This goes over here. Then we set our next's next to point to the front of the linked list. And then finally, we set our head to be next so that our next would be the, whoops, this is wrong. Then finally, we set our head to be next, so that our next would be the front of the linked list. And that's how we would manipulate our pointers to reverse our linked list. Now I won't go through the whole example again, as we already done it. So we'll just continue on. And then after we did all our arrangement and finished our while loop, we just return our head. Now let's run the code. And there we go. That's how we would do it iteratively. Now let's look at how we would solve this problem recursively. To solve this problem recursively, we would somehow need to retrieve the last node while also manipulating the pointers around as we recursively travel towards the end and propagate back. Initially, I thought this problem was pretty straightforward. We just go all the way to the end, and then we return that node. And then in the recursive case, we would just point the node that we just received and point it back and set its next to be our current node. Then we would return that node back to the function that called it previously and set its next to be the current value, and then we continue so on and so forth. And then we do the exact same thing. But the problem now is that the node that we receive back after we run our recursive algorithm is that it is the last element in the list. And so yes, we reverse the list. We only have a pointer to the last node in the list, which unfortunately does not do us any good. Looking back at where I went wrong, where I returned the end of the list, we didn't really need to do that because if we remember, the front of our list is the last node. It is 3. What we actually need to do is we need to continuously return the front of our list back. We just need to adjust our algorithm a little bit. We still have our base case, which is we find the end of our node and then return that. We run our recursive algorithm. We go to node 2, we go to node 3, and then node 3 is next is null, so that's our base case. We return node 3 back over here, and we have access to our head. We would just continue returning this head back. But while we are doing that, we need to rearrange the pointer of our current node that we're in. What we would do, so at this point, where would 2 be? 2 would be over here, which means that we need to set our next, which in this case is also the head. We need to set our next to be our current value. So this would go here. And then current.next will become null because it is the end of our list. And then we will continue propagating back our head. So now we go back to our previous stack and we're back over here. Our next node would be over here. We would do the exact same algorithm. We would set our next's .next to be cur. So right now our next is null. So this would point over here, and then we would set our current to be null. And then we just continue returning the front of our linked list back, which would then give us our answer. So now following this path, we start from 3, go to 2, which then points to 1. And that is our answer. To get started, for all recursive function, while it's not necessary, I like to define a private helper function to handle everything and just return the outputs of that as my answer. And for all recursive functions, we need to define both our base case and our recursive case. Our base case is when we reach the last node of our linked list. Otherwise, we have our recursive case. So in this instance, we just need to get the node first, go all the way to the end, and then we can manipulate our pointers on the way back. In our code right now, we start at the head. We would recurse to the cur.next, and then we would go until we reach our base case, which then we return our current back as, let's say, end. So we're back here, and we have end point as our list node number 3. what we need to do is we need to manipulate the pointer so that current.next points to current, and eliminate currents pointers. What this does is, first we create our next node, which point to currents next. So that's over here. It's just for convenience. We set next as next to be current. So next goes to current. We set current.next to be null. So currently, right now, just from looking at 3 and 2, 3 points to 2. And remember, we want to return our last node back because it's going to be our front node. Now, let me clean up our example for a bit. At this point, we just finished processing our 2 node. Now we're back at our 1 node. We'll do the exact same thing that we did earlier. We set a variable next to be our current.next, and then we do the same manipulation. We set our next.next to point to current. So next.next points to current. And then we get rid of currents.next because now this is the end of our node. And then we return our end back, which then would give us our answer. So from end, we have 3, which points to 2. And then we have 2, which points to 1, and 1, which has nothing, thus reversing our linked list. Now let's run our solution. And there we go. This is how we solve the classic interview question, how to reverse a linked list, both iteratively and recursively. This question really tests you on how good you are with pointer manipulations, and I highly recommend drawing out diagrams for any linked list questions that you encounter, just like what we did today, and then translating that into code. Now, if you like this video, please like and subscribe to get weekly and / daily updates. Otherwise, if you have any questions or comments, leave them below. Otherwise, bye. Have a great day.